Hi, I'm Julia Bonin. Today we're at Spring Peeper Meadow, where I was the site manager for 14 years.
I'm Sue Galadowicz of the University of Minnesota. I've been the scientist in charge of research and monitoring here at Spring Peeper Meadow. When we began this restoration, there was a lot of uncertainty. No one had ever been able to restore a sedge meadow from a drained agricultural field filled with an invasive species like reed canary grass. We knew that monitoring was going to be very important for the kinds of restoration decisions we were going to be making over time. We've decided to focus on vegetation and hydrology since most of our restoration actions would involve those. We wanted frequent data on hydrology because we were uncertain how the hydrology would reestablish after we broke the drainage tiles. We also were concerned about how the seeded and planted plants would react to the water levels that were developing. For hydrology, we needed to track changes in both surface water and groundwater. Changes in surface water can be easily measured from a staff gauge placed in the lowest part of the wetland. We decided to monitor surface water elevation weekly and then after storm events. We assumed that level of information would be valuable for understanding how our vegetation was responding to the conditions on the site.
We didn't manage to collect that surface hydrology data weekly, but we collected it very frequently, often enough that we were able to make management decisions based on that. So that monitoring information was very important for us to know that the plants were going to establish successfully during those first couple of years during establishment. In addition to surface hydrology, we measured groundwater.
Yes, tracking groundwater was important because we were uncertain whether groundwater would be an important input to the water supply here at Spring Peeper, and we had no additional information prior to restoration. To monitor groundwater, we installed 9 sets of wells. Each set consists of 3 PVC tubes, each one intercepting water at a different elevation. These are called piezometers. They allowed us to determine if water was moving into or out of the wetland via groundwater.
So the piezometers were installed at different locations around the wetland, both down in the basin and around the perimeter. What we learned from the piezometers was that we do actually have some groundwater input on the east side of the wetland. And luckily we found that out before the piezometers got all clogged up with mud and they're not useful anymore.
Monitoring vegetation in addition to hydrology was, of course, critical because we were interested in eradicating reed canary grass and reestablishing sedge meadow and emergent marsh vegetation. We used 4 different approaches for monitoring vegetation. First, we recorded all the species that we encountered across the entire site. And then secondly, we did a lot of these really small plots where we could get a lot of detailed information that showed us the relationship between species and the hydrology. We also monitored vegetation across the entire wetland using 28 large plots. And then finally, we did invasive species population monitoring. These last 2 methods, the large plots and the invasive species population monitoring, were the most important of the monitoring that we did.
The 28 large monitoring plots are set up to correspond to 5 elevational zones across the wetland. We have a system of colored poles here that mark those contours around the wetland, so we have a nice way of permanently recreating those plots each year when we do the vegetation monitoring.
We monitor these plots every 4 years, recording the cover of all the species twice in the growing season, so we're sure to capture both the early season and the late season species. It's more important for us to take vegetation data less frequently but more thoroughly because vegetation doesn't change that rapidly, as opposed to doing a rapid evaluation very frequently. The large plot vegetation monitoring gave us excellent information for several things that we needed for restoration decision making. First, it allowed us to know which of our seeded and planted species had colonized. Second, it allowed us to detect changes in abundance of our native species over time. And third, it gave us an overall sense of how our invasive species control program was doing.
One thing that the large plot monitoring didn't allow us to do was to monitor the vegetation frequently enough to manage our invasive species adequately. So we had a more frequent system of monitoring where we very systematically walked through the wetland using the pole system as a grid format, and then we're able to pick out where invasive species were a problem on a regular basis during each growing season. In addition to monitoring hydrology and vegetation, we also monitored amphibians, breeding birds, and water quality here at Spring Peeper Meadow. So with our very thorough monitoring program, we feel pretty well set up to continue our adaptive management program into the future.